Okay, good morning, everyone. It is now Saturday, and I am back in a very, very snowy Toronto. And this is part three of the lecture that was scheduled to be given on the 24th of January. And here I'm going to be talking about three concepts that are of great importance to information retrieval, which are Boolean logic, recall, and precision. Now, Boolean logic came about from the philosopher George Boole in the mid 19th century, and it was a way of automating logic on the basis of binarisms. Something is present or something is absent, and if it's absent, it's zero, and if it's present, it's one. So as you can see, the vector graphic method that I discussed in part two grows out to some degree from the Boolean logic principles. Now, Boolean logic has been part of large-scale information retrieval systems since the 1950s, but it's worth looking at because Boolean logic is one of the earliest forms of impressing logical reasoning into computational systems. And much of the machine learning algorithms that Google is at the cutting edge of developing arise from the very principles that inspired the use of Boolean logic in information retrieval. So, to our eyes, it looks rather unsophisticated compared to what algorithms can do now. However, it's worth thinking about. Now, the basic idea behind is that concepts can be gathered together into sets, and then those sets can be combined together using set theory, using and or not to join them. Now, it's important to remember that Boolean logic is counterintuitive in one respect. If I say to you, I want apples and oranges, that sounds like a fairly large set. Whereas if I say I want either apples or oranges, that sounds like smaller because in the first example I was willing to consider both apples and oranges, and in the second I was willing to consider only apples and not oranges. Either apples or oranges, but not both. Now, it's important to recognize that it flips around when you're dealing with Boolean logic. If I say, give me all of the documents that mention the word dog and the word cat, it means that all I want is that subset of documents that mentions both of them. So if you look at the Venn diagram that we've got here, we've got a set of documents, D1, D6, D2, and D4, which mention the word dog, and we have three documents, D2, D3, and D7, which mention the word cat. If I say give to me all of the documents that mention both dog and cat, my set is going to be one document, D2, because that is the only document that mentions both. However, if I ask the system, give me all those documents that mention either dog or cat, then it will give me everything because all of the documents in these two sets mention one or the other. So if I'm asking for dog and cat, I'm asking for a smaller set of documents than if I ask for dog or cat. And one of the things that search engines do, that search engine designers do, even today, is decide in their basic search engine design when people enter, when somebody enters a query of two or more words, are they going to be combined with and, or are they going to be combined with or? Or gives you more and gives you less. Here we go. Sorry about that. If we ask for dog, not cat, then it means I want all of those books that mention dog, but do not mention cat, which means I'd have three documents that mention dog exclusively, and I'd omit D2 because it mentions not just dog, but cat as well. Here we go. Now, along with the idea of retrieving information came the question of how do we estimate or assess the success with which we have retrieved information from a document store. And there are two classic measures of success that developed in the late 1950s: the concept of precision and the concept of recall. Recall is a ratio of the number of relevant items you retrieved relevant to the number of relevant items available. So let's say, for example, there are 85 articles on cardiofasciocutaneous syndrome in the database. I received 75. My recall, therefore, is 75 out of a possible 85 documents. There were 85 things there that matched what I wanted. My query only retrieved 75 out of 85. So that is recall. It takes all of the things that are useful to you within the database, and it finds how many you retrieved, and it measures those as a ratio. Out of all the things that you could have gotten that would have been helpful to you, how many did you actually get? That is recall. Precision measures what you actually got. So it says it is the number of relevant items you retrieved relative to the total number of items retrieved. So let's say I retrieved 42 articles with the query CFC. 30 of them were on cardiofasciocutaneous syndrome. The other 12 were on chlorofluorocarbons, which is a completely different concept altogether, but which also goes by the acronym of CFC. Here, I achieved a precision of 30 out of 42. Out of the 42 things I received, 30 of them actually met my needs, and the other 12 were superfluous and unnecessary. Now, ideally, when you are searching, you want to get both maximum precision and maximum recall. You want to get everything in the database that is relevant to your query, and you want to get only those things that are relevant to your query. Here is the sad truth of it. Traditionally and historically and to this day, recall and precision are inversely related. If you want high recall, if you want to maximize your chances of getting everything a database has to offer, chances are you're going to have imprecise results. You're going to find that along with all of the good things you got a lot of dross in there as well. If you start with a high level of precision, then it means that your recall is going to be low. So if I start with CFC, for instance, I might get very high recall, that I might get a lot of stuff that's related to cardiofasciocutaneous syndrome, but I will also get a lot of icky stuff in there, the stuff that doesn't matter. If I start with a term like cardiofasciocutaneous syndrome, I may get a small number of articles that are precisely relevant to my query, but I may miss out on articles that called it by a different name, that referred to it briefly within an article that talks about things on a larger scale. There may be all kinds of things that I missed in my effort to be precise. So the story of information retrieval is one of negotiating these two inversely proportioned measures of success. If I start with high recall, typically my precision is going to be low, and if I start with low recall, typically my precision will be high. So that's it for this part, and now we'll go on to part 4, which talks about strategies of dealing with this.